Hello everybody. In today's video we are going to be looking at the solutions to the College Prep Magnetism homework problems 11 through 15. Let's take a look at number 11. We have a wire that is 0.5 meters long and carrying a current of 8 amps. It is at right angles to a uniform magnetic field, and the force on the wire is 0.40 newtons. What is the strength of the magnetic field? Let's take a look at our given values. We are given the length of the wire at 0.5 meters. We are given the current, which is 8 amps. And we are given the force, which is 0.40 newtons. And we are being asked to find the strength of the magnetic field. So if we are given the length of the wire, the current, and the force, looking for the magnetic field, we're going to want to use F equals ILB. Solving that for B, we get B equals F divided by I times L. Plug in our known values, and we should get a magnitude of the magnetic field of 0.10 Tesla. Problem 12. The current through a wire that is 0.80 meters long is 5.0 amps. The wire is perpendicular to a 0.60 Tesla magnetic field. What is the magnitude of the force on the wire? Again, looking at our known values, we are given the length, which is 0.80 meters, the current of 5.0 amps, the strength of the magnetic field at 0.60 Tesla, and we are being asked to find the force. Because we're being asked to find the force, we are given the length, the current, and the magnetic field. We know we need to use F equals ILB. Don't need to rearrange it because we're already solved for our unknown. So we just substitute in our known values of 5 amps, 0.8 meters, and 0.6 Teslas, and we are given the force of 2.4 newtons. So this one should have been pretty straightforward for you guys. No rearranging. It's just kind of a plug and a chug problem. Problem 13. The force on a 0.80 meter wire that is perpendicular to the Earth's magnetic field is 0.12 newtons. What is the current in the wire? And they want us to use 5.0 times 10 to the minus fifth Tesla for Earth's magnetic field. So we are given the length of the wire at 0.80 meters. We are given the force on the wire, which is 0.12 newtons, and the magnitude of the Earth's magnetic field at 5.0 times 10 to the minus fifth Tesla. And we are being asked to find the current. What is the current right there? So again, using F equals ILB, in this particular case, we have to solve for I, or for current. So we rearrange the formula. We get I equals F divided by L times B. Substitute in our known values, and we should get a current of 3.0 times 10 to the third amps. One quick note before we move on to the next problem. All of these should be relatively straightforward. The one thing I do want to point out is that you'll see this word perpendicular popping up a lot. And remember from the PowerPoint that in order for the force to be acting at its maximum value, the current and the magnetic field have to be at right angles to one another. That's why we have all three axes. So everything has to be at a right angle to each other. So we're going to assume, unless otherwise stated, that everything is always going to be at 90 degrees or perpendicular. But that's just an important point to remember, especially when it comes to the test that you're going to be taking on magnetism and electromagnetic induction. So just keep that in mind. Problem 14. A muon, which is a particle that has the same charge as an electron, is traveling at 4.21 times 10 to the 7th meters per second at right angles to a magnetic field. The muon experiences a force of 5.00 times 10 to the minus 12th newtons, and they want to know how strong is the magnetic field. So let's take a look and see what we are given in this problem. We know that the charge of a muon is the same as an electron, which is going to be 1.60 times 10 to the minus 19th coulombs. I know that the velocity or the speed that it's traveling at is 4.21 times 10 to the 7th meters per second. And the force acting on the muon is 5.00 times 10 to the minus 12th newtons. And they want to know how strong is my magnetic field. So in this case, I am given the charge and the velocity and the force, and I'm being asked to find the strength of the magnetic field. So I want to use F equals QVB for this problem. Again, solving for B, or the magnetic field, I'm going to rearrange the formula, and I'm going to have B equals F divided by Q times V. Plug in all of my known values, and I am going to get a strength for the magnetic field of 0.742 Tesla. The second part of 14 asks, what acceleration does the muon experience if its mass is 1.88 times 10 to the minus 28 kilograms? So now we're given a mass for the muon, and we are looking for its acceleration. I know from the previous part of the problem that the force acting on the muon is 5.00 times 10 to the minus 12th newtons. So if I have the force and I have the mass, I can use Newton's second law, F equals ma, to find the acceleration. So using F equals ma, I want to solve that for acceleration. I get the acceleration is equal to the force divided by the mass. I plug my values in, and I should end up with an acceleration of 2.66 times 10 to the 16th meters per second squared. Problem 15. In this problem, we are given a singly ionized particle which experiences a force of 4.1 times 10 to the minus 13th newtons when it travels at right angles through a 0.61 Tesla magnetic field. They want to know what is the velocity of the particle. If you remember from the previous set of homework problems, 8 through 10, we talked about ionized particles, and ionized particles are just particles that have some multiple of our elementary charge. In this case, the particle is singly ionized, which means it is a multiple of 1 of our elemental charge of 1.60 times 10 to the minus 19th coulombs. We are also given the force of 4.1 times 10 to the minus 13th newtons, and the magnitude of the magnetic field, which is 0.61 Tesla. And we are being asked to find the velocity of the particle. So again, we're given the charge, the force, and the magnetic field. For looking for the velocity, we are going to want to use F equals QVB. Solving that for velocity, I'm going to get velocity equals F divided by QB. Plug in my known values, and I should end up with a velocity of 4.2 times 10 to the 6th meters per second.